Hello, I am Robert Miller. We're going to talk about a particular test you can do for testing the assumptions of homoscedasticity and linearity, which are important assumptions in multiple regression analysis. There are separate videos, one on homoscedasticity and the other on the assumption of linearity. So you might want to look at those first if you haven't already, and then look at this tape to look at how you can test for those assumptions. Because they are important assumptions. So it's one thing to know what the assumption is, the assumption of homoscedasticity or the assumption of linearity, but then you should also know how to test for it to see whether you've met the assumption or not. Okay, so one way to do that is to engage in the following plot. And with different statistical packages, this may be more straightforward or less straightforward. With SPSS, it's more straightforward in multiple regression and your linear regression analysis. Under plots, so the plots dialog box, you'll see something called Z-res and Z-pred. And Z-res are your standardized residuals. So the Z is for standardized and the res is for residuals. And then Z-pred is for your standardized predicted values. And so your Z again is standardized and the pred is for predicted. And so in SPSS, it's a straightforward matter for doing this test. For other statistical packages, you may actually have to generate your standardized residual values and generate your standardized predicted values and do the plot yourself. So I'm not sure right offhand how intuitive it is to do this test in other statistical packages. But in SPSS, it's straightforward. So what you want to do is you want to plot your standardized residual values. So here we'll have it as your standardized residual values. Do it here as standardized residuals, known as Z-res in SPSS. You want to plot them against you want to regress them on, I guess one could say, on the x-axis. Your standardized predicted values. Okay, or as it's indicated in SPSS as Z-pred. Okay, so one thing I want you to note, this is our y-axis, our vertical axis. This is our x-axis, our horizontal axis. And in some depictions of this, you have your standardized residuals on the y-axis and your standardized predicted values on the x-axis. But just to keep things just as clear as possible for you, okay, with no confusion, and I'm being sarcastic now a little bit, I have to admit, because it'd be nice if you always saw this particular presentation, but sometimes you'll see it switched around, okay? Don't be confused by that. Sometimes you'll see the standardized predicted values over here on the y-axis and your standardized residuals over here on the x-axis. It really doesn't matter which way it's done. Okay, what I'm going to say next applies in either case. Okay? All right, so when you look at this, this graph, this plot, what you want to see is a bunch of dots, and we'll just call them dots, that look like they're in a random pattern. Like you took some spaghetti and you just threw it against the wall and you just got a random splat of spaghetti. Now this doesn't look as delicious as spaghetti does, I have to say. Makes me hungry to use such examples. But it's the same idea. You're just taking some spaghetti, plop like that onto the wall, just a random pattern, right? That's what you want to see. You want to see a random pattern of dots. And if you see a random pattern of dots, then what that means is that you have met both the assumption of homoscedasticity and the assumption of linearity. All right? So you see a random pattern of these dots, no particular form or shape to them. You've met both assumptions, the assumption of homoscedasticity and the assumption of linearity. Okay, but maybe, you won't see that random pattern of dots. Now I'm looking for my eraser here. I'm going off camera for a second so I can get my eraser. All right, so here we are, back in action here, folks. Let's say you don't see that random collection of dots, but you see something like this instead. You see like a funnel shape. Okay, like a funnel shape. And when I see that, I think about like if I'm, pouring oil into my car, right? I take a thing, I go like that, right? Take the oil can and go like that. I may be dating myself to give an example like this. I don't even know if people do this anymore, but anyway, you take like one of those funnels like that, and then you take an oil can, you go like that, and you pour the oil into your engine. It's a funnel shape. If you get a funnel shape, and this is just one example of a funnel shape, it doesn't matter what its particular orientation is, okay? You could have the funnel shape, going this way, okay? Or going this way. I can't really do it going the other way, but like going like, it could be going like this, okay? It can go in any particular orientation, it doesn't matter. But if you have this funnel shape, what that means is that you have not met the assumption of homoscedasticity. That instead you have heteroscedasticity in your data. Okay? So whenever you see a funnel shape to the dots, in any particular orientation, it doesn't matter, the orientation of the funnel, it doesn't matter. That means that you have not met the assumption of homoscedasticity, but instead you have heteroscedasticity in your data. Okay, so now let's look at this pattern instead. Let's say you get a pattern like this. Okay, well, we'll draw a line through that, and you'll notice that we have a curve in our data. Well, whenever you have a curve in your dots here, okay, what that means is that you have not met the linearity assumption. That the relationship between your outcome variable and at least one of your predictor variables is not linear. It's curvilinear, all right? And so that means you have not met the linearity assumption. Okay, now again, this is just one example of a curve that you could see in the data. It doesn't, matter what the particular nature of the curve is. Okay, it can be like that, or it can be any of many other ways that you see a curve. Perhaps you see a curve like this. So you have a curve like this, okay? That's a curve in your dots. And whenever you see a curve in the pattern of the dots, that means that you have not met the linearity assumption, okay? So you don't want to see a funnel shape or a curve in your dots, because if you do, then it means that you, with a funnel shape, that you have not met the homoscedasticity assumption, and with a curve in the dots, that you have not met the linearity assumption. And so there you are. That's how you test the assumptions of homoscedasticity and linearity. You have a good day.